Let's try problem 7.20. A 4-meter long, 500 kilogram steel beam extends horizontally from the point where it has been bolted to the framework of a new building under construction. A 70 kilogram construction worker stands at the far end of the beam. What is the magnitude of the torque about the point where the beam is bolted into place? Okay, so first let's just go ahead and draw the picture. So we got a wall with a beam. It's a little longer. And there's a guy at the end of the beam. And so the only forces that are going to be applied to this beam are going to be the weight of the man, right, which is going to be applied at the end of the beam. Weight of the man. And then also the weight of the beam, which is applied at the center of mass of the beam. So call this W sub B. So these are only two forces that are going to cause torques for this problem. So if you remember the equation for torque, which is going to be torque is equal to F R sine theta, we see that theta in this problem is going to be this angle right here, from this horizontal point to this angle right here, which is going to be negative 90 degrees. So the sum of all torques is going to just be the weight of the man times the radius, so the wall to the man, which we're told is 4 meters, times the sine of negative 90, which is just going to be negative 1. So I'm just going to put a negative out front over here. And then plus the second torque, which is going to be the first force, which is weight of the beam, times the radius. So it's going to occur in the center of the beam, right? So the whole beam is 4 meters long. So from here to here is 4 meters. So half that is just going to be 2 meters. And then times the sine of theta. And theta for this one is also going to be negative 90, right? From the horizontal down to this angle right here. Negative 90. So it's going to be times negative 1, so I'm just going to put the negative back out front. Okay, so now we can just fill in our numbers. So the sum of all torques is going to be equal to negative, and weight is just mass times gravity. So the mass of the man is going to be 70 kilograms. Times gravity, 9.8 meters per second squared. And this is going to be times 4 meters. Minus the weight of the beam, which is going to be mass times gravity again, so it's 500 kilograms. Times gravity, 9.8 meters per second squared. And then times 2 meters. And if you plug this all in your calculator, this comes out to negative 12,500 Newton meters.